Oh, I guess those should start and we'll see. Yeah. Okay. Hello, everyone again. For the second day of our Intro to Unix workshop. So I'll get started for today. So let's see. So just a summary, yesterday we saw how to navigate through files, move, delete, create some files, etc., list files. And today we're mostly going to see how to visualize files and start processing them, do some basic processing on them, and also how to work with regular expressions. So just a summary of yesterday, that's the command we mostly see. So I'm going to just go through them quickly. So pwd is for print working directory, which allows you to display your current path. mkdir is to create a new directory. cd is to change directory, so to move in your tree structure in your folders. ls is to list files and some informations on file, such as size or date or so on, permission. chmod is to change the mode, so basically it's file permission. vi, we also saw vi and nano, which are two text editors that you can use to create file. We saw cp to copy some file, mv to move or rename files, rm to remove a file, aliases to create like a shortcut in terms of command, so to change like the behavior of some command. We also saw man to get more information on the manuals on the command, ln, which create links between file or folders. We saw find very quickly, which can allow you to find some files based on their name or some pattern. We also saw how to change a password, how to create a compressed archive with tar, and how to do some file transfer using SCP or SFTP or using a SFTP client. Okay. So for today, well, first we're going to start by doing the same as yesterday, open an SSH client on your computer, and then connect to Huffman2. So please do that on your own, whatever client you used yesterday or you decide to download yesterday, and I'm also going to do that. Okay. Let you connect. And today, so we're going to work on file, even though it's not anything very computer intensive. I thought it would be better if we all request an interactive session. That means like a shell on a compute node instead of on the logging node. And so once you connect it to Huffman2, if you type this command, the qrsh command, that's how you would request a session. For here, you request it for 3 hours with that amount of RAM, basically. So we can all do that. And be careful, don't put any space after the comma, otherwise it's not going to understand your options. And it's going to take a while. I mean, it shouldn't take too long, but basically it's going to take a bit of time to find a node for you. So it might take a couple of minutes, or yeah, it shouldn't take too long. So we'll wait until you get node. Okay, so you see, now have a change. So you see before I was on login 2, which is the login node, and no, I'm on the compute node 2008. And so that's how you can distinguish them, basically. If it's written login something, that means you're on logging node. It's written and something, that means you're on one of the compute nodes. And here you don't have to worry too much about like doing computing intensive task. Should be fine. And you need to say how much you're requesting in terms of time or RAM, basically. Okay, so I'll wait a bit longer to make sure you all have a interactive session. Okay. Let's continue, I guess. We'll get one soon anyway. Okay, so for today, I put some material on my GitHub account, so I'm going to send you the link on the chat, and then you can download the material for today. And you can either download using the git clone option on Hoffman 2, as I wrote down, or you can also try to transfer the file as we've seen yesterday. If I can write in the chat. If I can copy in the chat. That works. Okay, so I just sent you the link in the chat. So you can go there and you can download the materials. I guess I can show it. So you'll be here. Then you can either copy this URL and then use the git clone. Oops. And use the git clone command with this URL to download directly on Hoffman 2, or you can also download it on your computer, or only download the right file on your computer with the download, and then transfer it to Hoffman 2 with the SFTP client that we saw yesterday. So either option work. Just try whatever you prefer. So I'm gonna use git clone on my hand. And if you want to use git clone, there is a copy on the GitHub page, but it's copying to the clipboard, but you can paste in your terminal. So to paste, you would press Ctrl-Shift-V. So basically almost like the usual Ctrl-V, just on the command line, you need to add the shift. And if you're on Mac, it might be Command-Shift-V instead of Control, but so that means you can copy in your clipboard and still paste it in the terminal. So like, just go back to that. Up to you. If you clone, it's going to create a directory that's called Intro to Unix D2. If you transfer it, then you can call the directory whatever you want. You can call it Intro to Unix Day 2, or you can put it in the Unix workshop we had yesterday, Day 2, for example. You're free. So I'm just going to do the git clone on my end. Okay, and so here I press Ctrl-Shift-V, and it's copied the URL. And if you do git clone, it's going to tell you download object and so on. And so if I list my object for today, so I should have an intro to Unix git something, and I don't see it, of course. Where is it? Oh, here. So I have my intro to Unix D2 that's been created here. So I'm just going to cd in that directory. And I'm just going to list the file so that you can see. So it's just a tar file. So saying if you download the file and transfer on the Hoffman 2, you'll have a tar file for now. So we're going to have to untar, as we've seen yesterday. So to extract the archive. So let's do that. And so we have all this file. And if I list my folder, as we've seen yesterday, I still have my tar file, but plus all these files for today. So I'm going to give you a bit of time to do that, and then we'll continue. I didn't plan to discuss homework. I mean, if you I should have asked if you have questions. You can ask me on the homework. I felt it should be relatively easy to be able to do that, so I didn't necessarily put an answer. But if you have questions on the homework, you can ask me. And for the exam for this workshop, I planned a small quiz for tomorrow. I'm gonna give you the link tomorrow, and it has 20 questions on the different thing you'll see over the 3 days of the workshop. At the end of the presentation, there was a practice slide. It was just basically practicing some command, like making directory and so on. I mean, it's not mandatory homework, but it's good to do if you want to. Your tar file. So Kevin Zhu asked that his tar file doesn't end in .gc. Did you download it from GitHub? Because on GitHub, you also have an option to zip. That's going to zip the folder. So if you first unzip the folder, you probably will see the tar file that's ending in GC. Yeah, you download it from GitHub. Let me pull back the GitHub. Let me go back. So when you download here, you can also press download zip. So it's probably zipping the full folder. So you'll have to unzip the folder, and then you're gonna get the tar file, and then you'll need to extract the tar file too. For the one that has an error, I'm not sure. I would just retry a bit later. Or no, actually you have a typo in GitHub. You have git fam. See? I'm gonna put the link again. Okay, so let me know if you still have issue or you still don't have the file for today. Otherwise, I'll continue soon. Okay, let's continue. If you have any issue, let me know. Okay. So today we're gonna see mostly how to display files in Unix in general. So there are a couple of ways to display files. There is different commands. There is like cat, less, head, and tail, and the text editor like we've seen yesterday. So to display file, you can also use nano or vim. But we're gonna discuss some other options today first. The first one we're gonna see is cat. It means concatenate files and it prints the output on the standard It's print what's in the file on the standard output, so it's your screen. And so that's very convenient when you want to display short, simple files. And the name means concatenate. It's also because cat can merge files. So if you give cat 2 files, it's going to put one after the other. So it's going to merge them. And the command for cat is very simple. You cat and then the file name you want to look at. So if I do that on, for example, states file that was in the tarball, then it's gonna just print to the screen whatever is in the file. So that's really good and very convenient, mostly when you have very small file. If you have a huge file, so like the large.txt, it's quite big, at least bigger. And yeah, same as yesterday, I'll definitely encourage you to try to type and do the same as me, so that you learn by practicing. So if we do the same command on the large.txt file, then you see it's not super convenient. It's big, so it's print like all the line on the screen, so you can scroll or go up, but it's still not very convenient when you have a big file. So cat is very useful for small files. Another command that's quite useful and mostly for longer file is less. So less will print in a paginate, in like something that has pages. So it's easier to scroll up and down when you have a big file, basically. So it just show your output, but page by page, basically. So if we do less of our large file, then, okay, you'll see it right on the bottom that we're in less. And to navigate through, same, you have up and down. And you also have the page up, page down. Like, it's actually exactly like the manual in terms of shortcuts. So up and down arrows, then you can go line by line. Or if you do F or B, then you could go page by page. And when you're done looking at what you want, you just press Q and it's quit. So that can be quite convenient if you have big files that you want to have or bigger files that you want to have a quick look at. So, and yeah, and how to go through something you use less, it's similar as a man page. So it's the same shortcut. I put them down here, up and down, F and B for forward, backward, page by page, and quit, and Q to quit at the end, to quit less. Yeah, I copied it from the manual. So yeah, so cat is very useful for small file. Less is maybe more useful for bigger files. But can be very useful when you have really big file, because sometimes you just want to see how the file looks like, what are the different fields and so on. So you don't necessarily need to see the full file. You just want to see some part of the file. And there's 2 commands that are very useful for that, which is head. And head only display the top lines of your files, but often it's enough to see how your files look like. And so if we do head on our large text, you'll see it's only print. So by default, it's the first 10 lines. So if we do head, then we're going to see what our files look like, and we're only going to see the 10 first line. You can change the number of lines that you want it to print. So you have an option that's -n. That's for the number of lines you want to print. So if you do head -n3 and then our large text file, then it's only going to show the first 3 lines. So you could print whatever number of line you want. You could print the first 100 if you wanted to. And so it's print to your screen the first 100 lines. The next one works exactly as tail. It's just kind of the opposite. As head, it's just kind of the opposite, and its name is tail. And tail basically will show you the end of your file. And it's work exactly the same, has the same options. It just prints the bottom of the file instead of printing the top of your files. So like here, if I do tell of this large file, then I get line from 991 to 1000 because I have 1009. And similarly, you can also specify a certain number of lines you want to print. You can put a space or not. It will be understood, and it's the same. So here it's only printed from 998 to 1000. So it only printed the last three line of the file. So these for command can be sometimes useful when you want to quickly know what's in your file without necessarily printing everything, or depending on if it's a big or small file. Do you have any question on this for command? Doesn't seem so. So I guess I'll continue. I mean, you can try to print other file. Let's do some more. Let's look at some more file first. We can print what do I have. I have another state rank, for example. So you can see. So here I see that I have like states and then a number. So that can be useful if you want to do some processing to know what the fields are and so on, what's in each column. And so now we're going to see how to process some file. So first command for that is cut. Cut is, well, I guess it's the cut part of the file. Basically, it allows you to display a specific part of the file, like either some characters, specific characters in terms of position, or some specific field, so specific column. And how cut works, so you have some option. If you want to see specific character at a specific position, then you'll use the flag -c, and then the position you want to output, and then your file name. If you want to extract some specific column, then you'll use the -d. D means delimiter. So here you basically specify what's the character between your different column. So in the case of state rank, or in the case of line, we could consider the white space is the delimiter. And then the F means field. And here you specify which field number you want to show. So basically which column you want to show. And then the file name. And so by default, separator that's used by cut is a tab. So if you have anything different than a tab, then you'll need to specify which separator it has to use with the D flag. Okay, so let's try that. So let's try that on our large file. So let's first try to extract the, and so you can, I'm going to do this. And here I'm specifying from the first to the third character. So you can also put range. So you don't need to specify a specific character. You can also specify a range of character or a range of fields. So here it's going to only show the first three characters for each line of our file. Basically, it's print lin, 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 lin. Because that's character 1, 2, 3. And you can put multiple, like argument, not really argument, but you can set a range and some numbers. So if you do a (6), then you're asking him to extract the character 1 to 3 and also the 6th character, which in our case, given that we didn't say the delimiter and so on, so that's the E would be the fourth character, the space would be the fifth, and whatever first digit of the number will be our sixth character. So if we do that, it's going to print the first three character and then the first digit. And so here I'm at the end of the file because I printed everything. So you can see that was 999, for example, and that was 1,000. So it's why we have a 9 here and a 1 here. And the beginning of the file would be 1, 2, 3. I guess most of the time when you use cut, you probably want to extract column. And so you would, in our case here, if we want to extract the line number, we need to specify the separator, which is space. So you would set D, the delimiter, and then you would put space. I mean, for it to understand correctly, you need to quote the space. So you'll put quote and you'll put space in between quotes. And then you're going to specify which field we want. So let's say we want the second field. Then you would just add a -F to specify the field number and then the 2. And then here you can see we extracted the second column, which is the line number. Okay. Yeah. Do you have any question on cut so far? Looks like no. Okay. So we'll continue then. So the next command that's going to be useful to process file is paste. Paste join lines of files. So how you use paste? You can use, so you will have the command, and then you'll have some flags, and then you can specify 2 different file names. Then similarly to cut, you can specify the delimiter with D, and same by default, it's considered tab as a separator. And you can also say if you want file to be joined in serial versus parallel. So we'll see later what the difference between those two is. So let's try on our 2 files, stat.txt and capital.txt. So let's first look at how they looked. So let me do head, because I don't necessarily want to print everything. So we can see with the state file, we have some states. And if I do the capitals, we'll have the capital of those states. And so if you had something like that and you want to merge, such that the state and the capitals are on the same line, then you could use space for that. That's what space says. So if we do space /d, here we specify what delimiter we want to put between these 2 files. So if we want, for example, a dash or a minus, and then if we do that on the state.txt and the capital files, then you see when you run the command, it's going to have taken the first line of one file and then merging with the separator we specified with the second, with the first line of the second file and so on. So then it takes the second line of the first file and merge it with the second line of the second file, and then put the delimiter we specified in. So that's what paste does. And so I told you there is also S option for serial. And if we do the same and add the S option, then instead of taking the first line of the first file and the first line of the second file, it's going to first merge every line of the first file. And then it's going to take the second file and merge every line of the second file. So we can see here the first line did merge all the states with the delimiter we specified. And then the second line merged all the capitals from our second file, same with the delimiter we specified. So that's the difference between parallel or serial. It depends if you want to put the first line of each file together, or if you want to merge all the line of each file and have one line per file, basically. Okay, is there any question on paste? Doesn't look like so. I mean, if I'm going too fast also, you can let me know. It's not working for you. What's not working for you? So paste. Oh, you forgot the E. It's paste. Does the number of line needs to be the same? That's a good question. I haven't tried with longer line. It could merge an empty thing with something. I'm actually not sure. We could try. Let's try to see if it would work if there is not the same number of line. I'm gonna just change my file just to see if it works. What do you have? Let's add Carolina, South Carolina. Yeah. Okay, and let's see if it would work if I do that now. So this one probably would work, I would say. Yeah, so this one did work with the serial because you process every file kind of separately. And let's see if the one without the serial. So yeah, it's also worked, but you see it put an empty. If the number is not the same, then it'll put an empty, like an empty line. Okay, so I guess we'll continue. So next thing that can be very useful, and that's probably something you're going to use at some point, is how, I mean, it's nice here. We're doing stuff, but it's all print on the screen. You might want to save whatever command you're doing into a file. You might not want it to print on the screen. How do you do that? So basically, by default, everything you run is going to print to the what's called standard output, which is basically your screen. But you can redirect this output to a file. And to do that, that's these two symbol. So it's like the greater than, which means instead of printing to a file, to the output, I'll print to a file. And by default, the single greater than will overwrite whatever files you say. So if your file exists, then it's going to overwrite what's in it. And if your file doesn't exist, it's going to create it. And if you put two of those greater than, then instead of overwriting, it's going to append to the file. So if the file doesn't exist, it's going to create it. But if the file exists, it's going to add new line to it, basically. And so how it would work is you would type your command, whatever you want. And then instead of just pressing enter, then you'll specify, OK, you'll tell to the terminal, I want you to, whatever you would normally print on my screen, I want you to put it in that file. And same with the append. And so that can be very, very useful to save whatever you're doing when you're doing text processing. So let's do that on our state and capital. So I told you before that cat. I'm going to remove the line I added in my states, just to have the same thing as you guys. Okay. So I told you before that the name from cat meant concatenate. That's because you can give multiple outputs to cat, and it's going to just put them, basically print them one after the other. So if we do that on our state and capitals, so you see it's outputs first whatever we had in the state.txt and whatever we have in the capital.txt. It just like print all the lines of the first file, then go to the second file and print everything. So this way you can merge file. What if we wanted to save that in another file? So we would run the same command, but instead of just pressing enter, we'll say redirect the output to a file that's called combine.txt. And let's do that. So no, it doesn't print anything to the screen, which kind of what we want. And it should have put it in combine. So let's see the file I have now. So you can see now I have a file that's called combine. And now that we saw a couple of commands to print whatever is in a file, we can try that. So we can use the same cat and just say to print to our screen whatever is in combine file. And we see it's exactly the same as we had when we just run the cat state capitals here. So it just saved whatever it would have normally print to the screen to a specific file. Let's not try. So if I was to print, if I write ls, so I get my list of file. But you could also do that with a lot of commands. So any command, basically, you could redirect the output to a file. So if I was to do that with ls, then I'm going to basically, in my combine.txt, I'm going to basically save my list of file. And given that here I'm specifying only a single greater than, it's going to overwrite. And that's what I want to show you. So now I do another command and I save to the same file. It doesn't tell me it's going to overwrite. It doesn't tell me anything, but it did just overwrite. And we can check by looking what's in the combine file. And you see now I have my list of files. So it just overwrite whatever was in there before. And yeah, feel free to do it at the same time and let me know if I'm too fast. And so if you don't want that, you can append instead. So let's just try the append. So let's take the first 3 line of our large file and append. So you see here I'm putting 2 of these greater than symbol. It's to mean append. So it's going to append to, and let's append to the same file just to see what happened. So it doesn't print anything to the screen again. So let's look at our new combine files. And you can see we still have our list of files, of file names. And then we have the first 3 line of our big file that had a lot of lines. You see that if I do put the double greater than signs, then it's not going to overwrite whatever was in the file before. It's going to just add new lines. Okay, any question on how to redirect thing on to files before I continue? Okay, doesn't look so. So I guess I'll continue. Another quite useful command is the WC. What WC means is word count. So you can do that command and for each file, it's going to count different things. So you can ask him to count different things. You have different flags here. So you can have count the number of bytes, which in most cases will be the same as character. Mostly if you don't have weird symbols, the character will be coded on 1 byte. It also has an option to show the number of characters, but in most cases, these two are going to be equal. At least, like if it's written in English, most of them should be equal. If you had a text file that was written in Japanese or something, then the symbol won't be coded on 1 byte, so they would be different. But if your files is in English, and these two are probably going to should be the same, basically. You can also specify the number of lines. So sometimes being able to know how many lines you have in the files, it's also quite handy. And like if you want to know if you have FASTA, and so for FASTA format, you'll have first line, that's a header, and then sequence. So you could count easily how many gene or whatever you have in your FASTA format, or same if you have FASTQ for RNA-seq, then the FASTQ format has 4 lines per read. So you could also easily count how many reads, for example, you have. So being able to count is sometimes very useful. And you can also count words. Basically, a word will be separated by blank characters, so either a space, either a tab, or things like that. So let's try on our combined file. And you can put multiple files, so you can count the number of words or line enough in multiple files at the same time. So if we do that, it's going to print us 3 outputs. So if we don't specify any flag, by default, it's going to print first the number of line, then on second, the number of words, and the last one would be the number of byte, which in most cases would be the same as the number of character. And we can see like our large .txt file, we can see it has 1,000 lines. And if you remember when I printed, so if I redo the head of our large.txt, so we have line 1, so just number from 1 to 1,000. So that makes sense that we have 1,000 lines. So if I redo the end, then it's just line 1 to 1,000. So, and we can confirm that when we did the WC, we had 1,000 lines. And it's also print the total of your 2 files, which not necessarily super useful. But yeah. And we can also see for this large file, we have 2,000 words, which makes sense because we also have the first word for every line. The first word is line, and basically the second word would be the line number. So that makes sense that we have twice as many words compared to lines. Do you have any question on WC word count? Doesn't look like it. Okay, let's do that, and then I guess we can take a short break after that. Next one is diff. Diff is also quite handy because it's going to show you difference between files. So the syntax is diff. You can specify some flag, and mostly the flag are going to specify how it should output the result. So it's mostly like display option. And then you'll have first file, which is file 1, and then second file. And basically you want to compare what's in those 2 files. And so in terms of option, these are quite handy. And which one if you ever need diff, which one you'll prefer to use, I guess it's really a matter of preference because the output is written differently. But these are quite popular, I would say. So you have C, that's a copied context, and we'll try that on some files so that you can see the difference in output. U is unified context, and Y is side by side. So I do like Y or U probably a bit more, but that's my personal preference. You might prefer C. Yeah, so that's more a matter of preference. So let's see how it looks. So we have these 2 files, small.txt and small2.txt. So first, let's print to the screen so that we can see how they look and what's the difference by ourselves. So if I cut the small text, have line 1 to 10. And if I cut the small text 2, then so I have line 1, 2, then 3, 3. So I have a difference here, and then have a new line between 5 and 6, and the line 10 was deleted. So let's see what the output of diff is. So let's try diff with the C first, the copied context first. And yeah, as I was saying, please try to do it at the same time. It's always useful. So if I do that with the C option, what it's going to tell me, so that's the first file, and you see it's also tell me that the stars means the small.txt. So here it's printing the small.txt, and what's saying here, it says that this line was changed and that this one was deleted when I look at the first small.txt file. And so the dash here is a small2.txt. And so it starts here. And what it says is that this line was changed. I mean, this line is different, basically. And this was added. So for each file, it's kind of comparing to the other file. It's not the output I prefer. I guess I'm more used to either U or Y. So let's see how U looks like. So U is a unified context. So it's basically merged both outputs. So it's more concise. And I guess that's one reason I tend to prefer it. And you can see here, it says basically with U, the reference is the first file you put. So the reference is the small.txt. And so if you compare to small.txt, here it says that the line 3 was removed and it was adding a line 3, 3. So if you have a deletion plus an addition, that's basically a change. So this line was modified from line 3 to line 3, 3. And then it says that between 5 and 6, you had a new line that was added. So that's a plus, and this line add new line. And it also tells you that the line 10 was deleted. So basically with the unified context, it's kind of merged both files. So it's a bit more concise. And the reference is basically the first file. And then you compare the second file to the first. And then I also like, because it's very visual, I also like the Y. And so if we do the Y, so Y is side by side. And I guess it works better if you have a bigger terminal. So I'm just gonna do it bigger. And so with the Y, so it's kind of printed in 2 columns. So the first column is your first file that you specify. So it's a small.txt. And the second column is the second file you specified, which is small2.txt. And then in the middle, it's writing basically what changed between the two. And I do like that because you're really seeing both. So it's easy to compare. And so this vertical line means this line was modified. And we can see that before it was line 3, and now it's line 3, 3. And so you can also see that here, this greater than means that it was added. So in the small2.txt, this line was adding, the new line was added between 5 and 6. And the smaller than means it was deleted. So we can also see it because it's side by side. We can see that before we had line 10, and now we have nothing here. So yeah, so as I was saying, it's kind of a matter of preference in terms of display, which option you're going to use. That's the free option are quite popular, and I guess really depending on yourself what you prefer if you ever have to compare files. Okay, so it's like almost 10. So I guess I'm gonna just check if I had something else on diff, but I don't think so. Yeah. So I guess we can take a small break. If you have any question, I'll stick around. And let's say we're gonna start again at 10:05. And yeah, feel free to try on different files or let me just pause the recording. Resume. Okay, so let's start again after this break. So the next command that you can use is sort. Sort basically is what, I mean, that's like self-explanatory. So sort basically can sort a file by whatever column you specify, and it can, by default, it's going to sort alphabetically, but you can also tell him to sort numerically. And how sort works is sort, then you have your options, and then you can specify which file you want to sort. And so I put a couple of comments here that are the most useful. So the key one means key. And basically it's sort by specific column numbers. However, and that's something not necessarily all people know, it's take whatever column number you give him, but it's actually take that column until the end of the line. And usually when we think about sorting in our mind, we tend to really think column by column. So I would recommend to use the column, comma, column. And that's here you specify between which column you want to sort. So basically, if you want to sort by the first column, you would specify 1, 1. So I would recommend always to do that because it's more like we think in our head, at least more like I think in my head when I want to sort by a specific column. So I would recommend to do that. And so key, basically you're saying by which column you want to sort. And then you have a couple of other options. So you can specify the delimiter of your file. I think by default, it's any blank character. So either space or tab, this type of character. But if you have a comma, for example, a comma separated file, then you could specify that your separator is a comma with the -t. You can also specify -n, which means sort numerically instead of alphabetically by default. And you can also specify -r, which means reverse order, and -u, which means only show unique line. So you could sort and print only unique line. And well, this one probably won't use so much, but by default, sort will always try to reorder thing in some order. So if you don't want him to do that, you can do a -s, and then it's gonna keep kind of the ordering you had before when there is ties. So let's try a few things of that to see how it works and what we can do with sort. So let's look at our state rank as this file. So if I print this file with cat, you see I have like state and I have like their rank in terms of population number, I'm guessing. So you might, if you have a file like that, you might want to sort your state by population number. And so if you want to do that, you can use the sort command that I just explained. And so what you would do is you would say, I want to sort by, and here I'm going to want to sort by the second column, the second field. And so I'm going to do 2. And because it's like, well, it's at the end of the line, so it wouldn't matter. But it's always better to write 2, 2. And then you're going to say, I want to sort it numerically, because by default, it's alphabetically. And so you have 2 ways of saying numerically. So if you put a -n, it's kind of globally sorting numerically, but you can specify that it's only this column. And I would tend to do that because I find it easier. I know that I'm specifying that this column is numeric. So I would tend just to put the n after my column position. And if we do that, we can see now that our file is reordered, and the first one is California, then it's Texas, then it's Florida, and so on. And if we didn't put the n, if we forgot, it would have sorted alphabetically. And sorting alphabetically, you can see we first have California because it starts with a 1, but then we have Michigan because it also starts with a 1. And so that's the difference between putting the n, which sort numerically, or not putting it. And while we have something numeric like that, we definitely want not to forget the n, because we'll want to not have 10, we want to have 10 after 9 and not after 1. And you can also sort alphabetically. Like if we were to sort them alphabetically, I would just take the same command and just change my key. And so I would say 1, 1, because I want to sort by the first column. And let's say I want to put them alphabetically, but in the reverse order, then I'll add the R. And same, you can put the R after the 1, 1, that you say, I just want to sort this specific column in reverse order. Otherwise, it would be a global order. And then we can see here that it's print or state in alphabetically order, but starting from Z to A. And then we have Washington first and then Texas. So if you have some file you want to process, sort can be very useful to have a quick sorting based on p-value or whatever, for example. So you can do that quite easily. So we're going to try on another file. I'm going to, so it's an inventory text. And yes, I really encourage you to try to do it at the same time as me. This way you can really learn them and learn the command and see what's happening. And you can also try something I'm not trying. Feel free to be a bit imaginative and try other things. So here I have like a text file that has an inventory. So it has some object and like a number of available items. And so you can sort. You can also sort by multiple field, basically. And how to do that? So here, let's say I want to sort them by how many available there are. So I would say I want first to sort them by the second column, the number of available items. And this column is numeric. So I want it to specify, I want to count numerically, to order numerically. And then you can add more. You can put space or not after the K, it doesn't matter. Yeah, sometimes I write without because it's shorter. It's one keystroke less, but it's up to you. So I'm going to first sort them by how many available are. So that's a K2, 2, and N because it's numeric. And then I'm going to sort basically the second column. You can sort by multiple column. And the second key is going to only be useful if you have ties. So here you can see have multiple objects that have 10. So I'm going to say basically, if you have ties, then sort based on the first column and just for fun, sort them in reverse order. But that's only going to apply after the first sorting criteria has been done. So, and if I do that on my inventory.txt, you can see I first have phone, speaker, earplug, and also one that had 10 then you can see that they're sorted in alphabetical order, but reversed. So we can see we have TV first, then PlayStation and computer. So that's basically it first sorted on the second column. And then I told him, if you have ties, which is these 3 lines that have ties on the second column, then sort in reverse alphabetical order. So you can put multiple key like that. So you could first sort by, I don't know, p-value or gene name in alphabetical order, then you can sort in something else. I mean, you shouldn't have 2 genes that are the same name. Yeah, I just wanted to show you that you can also sort by multiple column if needed, which can be quite convenient. Okay, do you have any question on sort? Looks like no, so I'm going to continue. Okay, so another command that's also sometimes useful, is unique. However, you have to be slightly careful with unique. So unique, what it does is it's going to remove it's going to extract unique lines. So it's going to remove any duplicated line. However, it only does that on consecutive lines. So if two consecutive lines are exactly the same, then it's going to remove whatever duplicate there are. And so there's a couple of options. So you have two here that are useful. So the -c, basically it's instead of like just removing the line, tell me how many, it's going to remove them, but it's also going to count. And so it's going to tell you how many of each line was present in your file. And D basically is it's kind of tell you, I don't want unique file. I want to extract the duplicated line. So it's basically whatever you would have, it show you what it should have removed otherwise. So let's look on the duplicate file that was in the material. So let's just print it first so that we can see what's in it. And so we can see we have a bunch of fruits. So we have apple, then we have oranges, orange, banana, orange, and pear. So if we do unique, and unique, be careful, I always make typos. So unique is end with the Q. So you don't have like the U and E. So that's sometimes annoying. So if I want to count how many line of each type I have, then I can do duplicates, and you can see that it's gonna, I had 2 oranges here, and now it's only writing it once, and it tells me I had 2 of them. So basically I have 1 line that's apple, then I had 2 lines that's orange, then 1 that was banana, and 1 that's orange, and 1 that's pear. So that's what I was saying. It's only going to remove line if it's consecutive line, if the duplicate are consecutive. So that's why it didn't remove this one, because it was not following any other orange line. So that's also why often when you use unique, you're going to do a sort first. Because if you sort first, then every duplicate line should be consecutive. And so then you're going to remove, if you sort first and do unique, then you're going to remove every other line. So if we do sort, and here I'm basically sorting on all the lines because I really want duplicate lines, so I don't need to specify any column. And anyway, I only have 1 column, but I'm basically really comparing each line in my sort. So you can first sort, and then let's save that as we saw. Let's not print that to an output, but save into a file that I'm going to call duplicate sorted.txt. And so let's just cat it just to see. So now you see it's sorted alphabetically because that's the default, and we have the 3 orange that's near each other. And now we can do unique on that new sorted file. Duplicate sorted. And so now if I do unique on that file, you see I have like 3 orange. Because doing the sort first did put them consecutively. And so I was able to remove all, to only keep 1 orange line instead of 2. So now we're going to see something else that's super useful, is a pipe. Pipe is this vertical symbol, and it's come from pipeline. So basically what it does is it allows you to combine multiple commands in one line. So basically you have your first command, then you put this pipe symbol. Oh yeah, because so I have a, let me first answer a question. So you did sort duplicate and then you write it into duplicate.txt, which is the same file. So basically you just overwrited your input file because you specified the same name. So in my case, I specify a different name. So I didn't overwrite my previous file. You can just re-extract the tar file, and then you'll have your duplicate file back. But yeah, that's just because you didn't specify a different name when you redirected your output. So that's why the append with the double greater than can be useful. But yeah, it's not going to tell you if you're going to overwrite anything when you redirect. Yeah, so let's go back to the pipe. So pipe is very, very, very useful. It's allow you to run longer or more complicated commands into one line. So basically, you're going to first run your first command, then you're going to pipe that in the second command. And so what the pipe does is it says to bash and to the shell, instead of printing the output to the screen, send it to the next command. So basically, whatever should have been printed from the first command is going to be used as input to the next command, and so on. And you can pipe multiple times. So you can have a lot of different commands and just piping whatever. So basically, what it would do, if you were to do a command, save into save to a text file, and then use that text file in the next command, then you could do that with just command 1, pipe command 2. And so it's basically just what we did. So let's try again. We just did the sort that we redirected to a file, and then we did a unique on that. So that means we could have done that just with the pipe instead in one line. And so let's try to do the exact same thing we just did, but with the pipe. So instead of saving to a new file, I'm just piping whatever output of the sort is to the unique command. And so you see, I get the exact same thing that was in my duplicate, that's the output of my duplicate sorted, but I didn't need it to save any extra file. So that's quite convenient to do multiple commands without having to save every temporary, like intermediary outputs. So pipe is like extremely, extremely useful. And you can have as many pipe as you want. So let's try a couple of things. Let's try to see if you can print what the largest free state in the state file are. So let's try. I mean, you have the answer, but you can also try to see if you understand. For the pipe, so there is a pipe question. So basically, the first file you specify in the file is in the pipe. It's going to be the input file for your first command, and then you don't need to specify any output file. Basically, I mean, you could specify one completely at the end if you wanted to save it in a text file instead of printing to the screen, but you don't need to save any intermediary file, basically. So you just need input. Yeah, instead of having input file, intermediary file 1, intermediary file 2, and output file, you just would have input file and output file. So let's try a couple of things. Try on your own to print like the 3 largest states in the state files, and try to count, for example, how many files you have in your current directory with pipe. So you have the answer, but make sure you understand them and try them on your own. And I'm also gonna do it. So if I want to print the 3 largest states in the state file, so let's just re-show what's in the state file. So that's this file. Oh, actually, I need the rank one because it has the order. Oops. Typos. Okay, so if I want the first top 3 state, then first thing I need to do is to sort that file. And I need to sort that file based on the second column, on the second column. So I'm gonna sort them numerically on the second column. So I would first need to do that. And no, I just want basically to print the first three. So what I can do is use what we've seen earlier, use the head, and only tell him I want to show only the first three line of whatever I sorted before. And you see it's directly just print me the first three. And I didn't need to save any intermediary file. And you could do that with basically any command. So if you wanted to know how many files you had in your directory, so to show how many files you have in directory, you can use ls that we used yesterday. And we just learned that we can count the number of lines. So you could do ls and send the output to wc, which counts with the -l, which will count how many lines there is in the ls command. And then directly it's going to tell you you have 15 files in your current directory. And we can check. I mean, here have like 3 columns of 5 files. So that's definitely does make 15. So that can be useful if you want to know the number of files you have and so on. Okay. So let's continue. And do you have any question on sort and unique? Doesn't look like it. Okay, so let's continue. Okay, so now what we're going to see, and I think it's a big thing, but that's the last thing for today, so we have plenty of time. It's a grep command and a regular expression, what we're going to see today. Grep means globally search a regular expression and print. So basically, you're going to give him some pattern, and then you're going to look if that pattern is found in your files and where it is found, etc., etc. And regular expression are a way to search for different pattern like at once. It's a way of coding a pattern that you can understand in Bash very easily. And so how grep works, you have like the command, which is grep, then you have a bunch of flags, and then you can shoot some string, and then you can specify, for example, in which file you want to look for that string. There is a couple of options that can be useful, like v, which is invert. So by default, grep is going to print the line that match your pattern, but you could also ask him to print the line that don't match the pattern. So that would be like with the option -v. You can also ask what's the line number with the -n. So what's the number where this string did happen. So instead of just printing the line, it's going to also add a number, which is a line number where that happened. You can also, instead of ask him to print, you can ask him to count the number of lines where you find this pattern. So, which can really be useful if you want to count something based on pattern, or so you can have the -c for that. You can also do grep on multiple files at a time. And you can also ask him, instead of showing wherever it match, you can ask him which file do contain a match. And then it's only going to list you the file name for which it's matching. And you can also specify, like, do you want your grep pattern to be case sensitive or case insensitive? So by default, it's going to be case sensitive. So that means capital letters are not going to be considered. I mean, if you have a small lower letter and capital letter, then it's not going to consider to be a match. So if you write small c and then you have a capital C in your text, that's not going to be a match. If you want that to be a match, then you need to specify the -i, which is insensitive. So that means it doesn't care if it's lower or uppercase. If you want more complex pattern, then you might need to use the capital E. It's extended regular expression, so you have a bit more, it's a bit more comprehensive in terms of what is understood. And we're not going to use it today, but these two options are also sometimes very useful. So the capital B allows you to show a certain number of lines before you match. And the capital A allows you to show a certain number of lines after you match. So sometimes if you like process some text, you can want to process based on the gene name, for example. But what you're really interested in is like the line after. So let's say you run a program that gives you gene name, and then the next line would be some summary statistic about that gene. And if you want to get the summary statistic for a specific gene, then you still have to search for that gene. But the output you're really interested in, not on the line where your gene is, it's going to be, for example, in the next line. And so that's why the -A and B can be useful, because it allows you to show either following or line before the match. So in what we're going to learn today, we're not going to use them, but they can be useful sometimes. And this option we'll use because it's going to be easier for you to understand regular expression. You don't have to use it in general. If you're processing text, you probably won't use it. But I think to learn, it's going to be very useful. It's a color. And basically, it's going to color the match when it's output the result. So that can help you to understand how your regular expression works and what's the exact thing that was matched to your string pattern. So I think for today, that's going to be useful. Okay, so let's try a bit of grep to see how it works. So let's go again on our duplicate text file, which has a bunch of fruits. So I'm just printing again what it has, because I always like to know what a file contains when I do some comment to like make sure I do what I need to do. So if I was to put a string like orange, and then I would say search for the string orange in this duplicate.txt file. Then, and I forgot to put the color, so it's going to just print me the line where this string orange is found. And if I put the color, no, it's like show me what was the match. So you found 3 lines with orange. So we could also say, I want to count how many times you find orange in my file. So if I add the C, so count is the -C option. And then instead of showing me the line with orange, it's just going to tell me 3. It means there is 3 lines that contains the word orange. So that's very useful if you want to count something based on a pattern. And you can also ask, I don't want you to print the line that have orange. I want you to print the line that don't have orange, which was the inverted match. And you can do that with the -V. And if you do that, then instead of printing 3 times orange, it's going to print everything that didn't add orange. So if we go back here, that was our original file. So we can see it printed apple, it printed banana, and it printed pear, because that's everything that's not orange. So that's how grep works. Yeah, let's try some more of these flags just for you to know what they do. So the other flags that were useful were like n, which adds a line number. So if I put my n, then it's going to tell me 2, 3, and 5 here. So that means the second line had orange, the third line had orange, and the 5th line has orange. And we can compare to here. So that indeed the second line, the third line, second line, third line, and fifth line. So there was a question for the count. Yes, you can multiple. Okay, so two questions. I'm going to answer the second one. You can definitely combine flags. So it's like with most commands, you can combine flag in one command. So you could count, say the number where you didn't find orange. So it's going to say the first line, the fourth line, and the sixth line. And there was another command for when it counts, does it count the time orange was mentioned or the lines where it was mentioned? So grep works by lines. So it's going to count the number of lines where the word was found. So it's like, yeah, it's a line based. It's not a string based. It's not going to tell you how many match. It's going to tell you how many lines had a match. And so if you do that on multiple, you can do that on multiple files. So I'm going to do that without option first. I'm just going to add another file. Let's say state.txt. So if I have two files, I said, basically what I'm saying is look for the pattern orange in these two files. And the answer would be, okay, I found orange in duplicate files. It's going to tell you in which file it found and just print the line. And so you can also do that with, you can add the -L. And instead of printing all the match, it's just going to print you, the file name for which a match was found. So instead of printing you every line that match, it just prints you the file where there is a match. So in that case, we only have orange in the duplicate.txt and not in the state.txt. So there is a question about the color. The color is just to put some color on the output, so to see better the match. So if you don't put the color, you don't have to. Mostly if you pipe into something, it doesn't matter. But then your output just look gray. So just to put coloring for the match and so on. So I found, I mean, you really don't have to use it, but like to learn how regular expression works, I think it's better to see it colored. So that's why I'm going to use it today. Okay, so that's for the main option you can use with grep. As I said before, there's a couple more options. You can use insensitive case and some others, but that's a couple of options that can be useful. And so now we're going to try to learn about regular expression. Oh, I have more. Oh, actually, I have more practice. Yeah, let's do more practice, actually. So let's look at this HG19 GTF. So it's a big file, so you don't want to print everything. So that's where the head is handy, because you're only printing the top of the file. Did I forget to put it? Oh, shoot, I forgot to put it. Oh, no. Oh, my bad. Okay, so I forgot to put in the material, so I guess we won't do that. I'm going to add it later after the course. I'm going to re-add it. Oh, I feel so bad, I forgot. Why did I forgot? Yeah, I'm going to re-add it, and then you can try that later. So, I mean, I can tell you, I won't do it. This file is basically a GTF file that's annotation for gene. And so you have like chromosome number, what the reference was. Then you have like exon position. So that's the start and the end. Then you have some other things that like if it's a minus gen and so on. And then you have like gene ID. So what you could want to do is try to only extract genes that are on, for example, chromosome 2. And then you could try regex. So you'll see that. But actually this doesn't work. So if you look at what you would have put in this file, and you can try that after, I'm definitely going to add this file that I forgot, and I feel bad that I forgot. I'm going to add it again in the GitHub, and then you can re-download the tar file, and it will have that after the lecture. So if you were to just do chromosome 2 here, then save that into a new file, then if you look at the output, you will have some chromosome 2, but you can see that you would, if you look at the end of the file, you can see that you would have also chromosome 21, actually. And if you do a sort unique, like to know what you have in your file, then you will see you have 1000 chromosome 2 and 1000 chromosome 21. So that means we didn't, our comment was not what we wanted. We just wanted chromosome 2, and we ended up, because we're not careful, also with chromosome 21. And so that's because chromosome 21 does start with CHR2, that starts with the same string, so it still did match. And I'm just like, that's just a small break, not a break, but like a small, it's a different command, but it can be useful. So that's why I wanted to put it here. It's a command echo. Echo allows you to display a specific text to your output. And for the regex, I thought it could be useful for you to use if you want to try more words, like not necessarily the word that I put in the file, but some other words. So if you do echo of hello, for example, it's just going to print hello on your screen. So you can pipe that into your grep, for example. So this way you could try more words just to see if you understand the regular expression, like words that are not necessarily in my file. So that's why I did put it here, because I thought you might want to try more. So yeah, let's learn about a regular expression. So what's a regular expression is? It's basically a string that you can use to describe several sequence of characters. So it can be a word, but it doesn't have to be a word. And there's a couple of specific characters that have specific meaning that will allow you to match more. So if you use a regular expression like CKS, and if you have a line that have this text in it, you'll have a match in terms of with this regular expression here. So like rocks here is going to match because it's end by CKS. And we can do that with the echo. So that's why I wanted to show you echo. I don't have any file that has this text, but you can write it with the echo. And make sure you put the single quotes or quotes at least. And then you would pipe that because you don't want it to print on the screen. So you can pipe that into your grep command. And let's see with the color and put the pattern CKS. Okay, and you can see that the output, it's print or line, but it also shows us that it did match this 3 character with our pattern. And you could change your text file. So next example is like, it sucks. And if you do change that, you'll see that we also match this part of the line. And you can write something else. So that's why I wanted to show you echo, because that can allow you to try more things that are not in the file, just to make sure you understand grep pattern. And if you have this line, then it doesn't print anything because it didn't find any match. Okay, and so regular expression. So as I was saying, grep is line by line. So you can have more than one match in a line, but it's still gonna just output the line because it's output line that have match. So if you were looking for apple and you had a line that had scrapple from the apple, then in that case, in that specific line, you would have 2 matches. So first one would match the end of scrapple, and then the second match would match apple. And so that's good, but I mean, it just still match very specific letter that you give him, very specific pattern. And what's nice about regular expression is that you can match kind of unknown things, or you can match, do very complicated match. So one of the most useful special character in regular expression is the dot. And the dot means it can match any character. So if you put O.K, you will want to match something that has an O followed by, well, you don't care about what it's followed, but you want that the second character that follows it is a K. And so if you were to do that on a line like this one, then you would have a first match here because you have an O, well, you don't care what's here, and you have a K. So folks would match this regular expression. And if you have looking, same. I mean, you have a ho here, and then, well, you don't care about the second character, and then you have a K. So that also would be a match because you don't care about what's the second character. And then here we have clock, and clock will also be a match because we don't care what the C is. So we can try that. Actually, I'm just going to retype. So if I do echo and I write this line, we're going to see what's on the slide. And now I'm just piping it in my grep. And let's say I want O, maybe I need O.K. Yeah, and we can see that it shows that this regular expression is a match for this part of the line, this part of the line, and this part of the line. Because we say we just want an O and we don't care about the character after the O, but we want the one after, like two after, to be okay. And so in that specific line, it matched 3 times. Now you can ask, what if I wanted to match a real dot? How would I do that? So regular expression have, there is like different symbols that have different meaning. And so one of those symbols that have a specific meaning is a backslash. And backslash is an escape character. So that means you can use a backslash to basically say, if the character that's following has a specific meaning, I don't want it to, I want to remove that specific meaning. So if you wanted to match a dot, because dot has a specific meaning, if you put a backslash dot, it will mean I want to match a real dot, not whatever specific meaning the dot has. So if you do that, if we try this on, let's say, hello, Leo, and I put a dot at the end, and I was to grab that with a color. So if I just put the dot as I was saying before, then the dots mean anything. So if I ask for that, what it's going to understand is I want a O followed by anything. I mean, I don't care about what is followed. I just want an O followed by something. So we have a match here where the O is followed by a space. So in that particular match, the dot means a space. In that particular match, the dot means a real dot, but it actually doesn't care what the second character is. So if we wanted only to follow match a dot that's followed, O that's followed by a dot, then we'll need to put a backslash before the dot in our regular expression. And that would mean remove the special meaning of the dot, and it would be understood as a real dot. And if I do that on the same line, you can see that no, it only matches the O that's followed by a real dot, and doesn't match the O that's followed by a space anymore. Okay. Do you have any questions so far? We're going to see more symbol for regep, so I don't want to just give you all the symbol and not let you digest everything. Okay, doesn't seem like any questions. I'm going to continue to other symbols that have other meanings. So you can, there is also, and that's also quite convenient, in character class. So character class are represented with the square bracket. And so if you put square bracket and a bunch of letters, then what the meaning is for this character, I want it to be whatever letter I put within my square bracket. So if I was to match this regular expression, B square bracket EOR, AT, that means I want to match a B that's followed by either a E, a O, or a R, and then an A and a T. So here you basically give him free choice for a match, which has to be either E, a O, or R. So if we had a line like that, beat a brat on a boat, then it would match these three words because you allowed the second character to either be a E, or R, or O. So that's how you could match for things, even if you don't know exactly what it is, or for specific. That's how you can match multiple potential patterns at a time with this type of character class, for example. That's allowed you to kind of or you allowed specific option for what's need to be a match. You can also say what you don't want. So same with this character class, you can negate it. And how to negate that character class is at the beginning of your character class, so you have square bracket, then you'll put an at, and then whatever you put after this at, it's going to mean I don't want any of this character. So here, what this regular expression means, I want a B that is not followed by neither an E nor an O. So it can be anything else, but I don't want an E or an O. And then I want an A and a T. So in our previous example, then the only match that would be found would be the brat, because here we have an E, so that's can't be a match. And here we have an O, and that can be a match because we say we didn't want either an E or an O. So in that case, the only match that's left is a brat. Okay, let's practice a bit that. Let's look at what we have in our regex.txt. So we have a bunch of this word, beat, brat, boat, bat, banana. So if you were to search for specific words, so you could grab, let's put again the color. You could grab boat in our regex file. And so you can see it's going to only answer boat because that's the only line that has boat. We could say, I want a B that's followed by something, which I don't care, but that's followed by something, and then that's followed again by an A and a T. And if we do that, we see we get a beat, brat, and boat, but we didn't get bat because the dot still means I want something there. So it's not like I don't care, it's there must be something there, but I just don't care what it is. So that's why bat, for example, doesn't match, because bat has nothing between the B and the A. And then we can try the character class. So we can try that, a O and a R. So here, I mean, I want B followed by either a O or R, then followed by an A and a T. And so if we do that, then we only have brat and boat that match. And you can negate that. So if you were to put if you were to put an A here, a hat here, that would mean basically I want a B that's not followed by O or not followed by R, and then followed by an A and a T. And then the only match that's left is beat. because all the others don't have, like brat is not a match because it has an R, boat is not a match because it has an O, bat can't be a match because there is nothing between the B and the A. So the character class is still a character. It just means whatever after that's whatever between the B and the A can't be a O or a R. So there still need to be something there. It just it shouldn't be a O or R. And then banana wouldn't match either because it doesn't have the AT at the end. And if you were to not put the AT at the end, so if you were to just do this regular expression, so that would mean you want a B that's not followed by a O or R. In that case, we would have the bat and the banana because the second letter is neither a O nor R. Okay. Let's almost 11. Let's do a small break before I overwhelm you with regular expression too much. Let's start at 10:05 again. And I'm gonna stick around if you have any question. And if you want, feel free to try more words with the echo, even if they're not in the file and so on. Okay. Well, let's learn a bit more about these regular expressions. So yeah, we were on a character class, so that's this square bracket. And basically you can put any letter you want in there, and that's only going to be matched for one character. So that means one character has to be ever whatever you put in the square bracket. So for example, if you have A, E, I, U, O, U, that means for that specific character, you'll need to match either A, either E, either I, O, or U. So for example, if you were to put a K, like in your character class in the square bracket, if you were to put a small k and capital K, then followed by orn, then you would match word like corn or corn with a capital K. You can also specify range for the character class, which can also be convenient. Instead of writing everything, you can specify a range. For example, if you were to write 1-9, then it would be the same as writing all the single digit from 1 to 9. So it would be the same as your square bracket 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can write range. So that can be convenient. Same with letters. You can also write range of letters. So if you were to put a square bracket A-E, like closing square bracket, then it would be the same as writing like opening square bracket A, B, C, D, E, and closing square bracket. So you have range. You can also combine multiple range. So you could combine the A to E and the 1 to 9, for example. You could also combine multiple letter range. So you could have A to E and then T to Z, for example. So you can combine multiple range. And so that makes it a bit shorter and less annoying to write if you need this type of thing. And so in square bracket, what you can notice is we use the dash character to specify range. And so this dash character has this special meaning only when it's used within two letters or two numbers. So if you were to start your square bracket with a dash, then you would really match dash, because it can't mean a range if it's the first one. So if you were to write opening square bracket dash 1, 2, 3, then you would match either dash, either 1, a 2, or 3. So the dash has this range special meaning only when it's between two numbers or between two letters. And so if you were to, there is also a couple of shortcut over meaning. for character class. So if you were to, you can write A to Z and capital A to capital Z. And basically that would match any alphabetical character. And there is also a shortcut that sometimes people use it. I mean, it's like longer to write, so I would not tend to use it. But where you have double square bracket, and you really need the double square bracket. And then you'd have column alpha, column closing, double closing square bracket. And that would mean any alphabetical character, and you have the same kind of shortcut with digits. So if you write 0-9 within square bracket, that would be the same as double square bracket with colon, digit, column, and closing square bracket. And you can also have alphanumeric characters. You also have a shortcut to that, that's alnum. Yeah, but there is different way to write it. So I guess I probably wouldn't use so much these two because they're a bit longer. This one might be annoying to type, so the alnum might be like easier to read, and it's like the same number of keystroke. So I would probably use alnum, but not necessarily too much the other. But they both would work. So you can, if you find the shortcut with the alpha or digit more legible, you could definitely use that. That's like equivalent, this thing. So there's a couple more symbols that have very special characters that can also be useful. And like these two are what's called hanker. And hanker are used to match the beginning of the line or the end of the line. So the hat would mean that needs to be at the beginning of the line. And the $sign would mean that needs to be at the end of the line. So if you were to write this regular expression, you would put the hat, which means I need the first letter of the line to be a B. So I need to start the line and it needs to be followed by a B. And then it needs to be followed by either an E, an O, or R, and then an A and a T. So on our previous example, then the only match now would be the beat, because that's the start of the line, and we specify we wanted the match to be found at the start of the line. And you can do the same with the end of the line, but instead of the hat, it's a $sign. So if you put your pattern here and then you follow it by a $sign, that would mean I need to find that pattern, but it needs to be at the end of the line. So you need the line to finish by a T in that case. I mean, to finish by that pattern, but the T must be at the end of the line. Okay, so let's try a couple of things with that on the regex2 files. So we can look at what's in this file. And so we have a bunch of like characters and numbers. And so we can try different regular expression on that files. I'm gonna again put the color because it's easier to see what's been matched. So if I do the first example, and please do it, invent new one, try new ones. So if I do that on my regex2.txt, so here I'm saying square bracket, capital A, lowercase a, and then 1. So basically I want A1, and I don't care if the A is uppercase or lowercase. So if I do that on my file, then I get these 3 lines and you can see it match either a lowercase a or uppercase A, and anywhere in the line. If you do the same, but for the pattern, you specify a hat before. That means you want to find this pattern at the beginning of the line. And so you can see now, we don't have this match anymore. So we only have these 2, because that's the 2 where this pattern is found at the beginning of the line. And we can try some more character classes, pattern. So we can try A, and then we can try 0, 9. So that would be A either lower or uppercase, followed by any digit, basically. And if we do that, we can see that on top of what we had previously, we also find this line that has A2 and A3. And you could do the same, but use a digit. So double square bracket opening, digit, double colon, and double bracket, and that would be basically exactly the same. So if you find easier to remember the double square bracket, column, digit, or easier to read, you can definitely use that. But it's exactly the same as 0-9 within square bracket. And we can also, instead of looking for digit, we can just try to look for any alphanumeric, alphabetic character by putting alpha. And that's include upper or lowercase. So that's any alphabetic character. And so you can see that in our text, it did colored everything that was a letter and nothing that was a number. And if you were to do digit instead, then it would do the opposite. It would color any number and like no letters. Okay, so regular expression. So right now, what we saw is relatively simple. I mean, still a lot of symbol to learn, but it has way more and sometimes can be useful. I mean, not necessarily all the time, but sometimes. And I guess one of the most important, would be the star. And the star has a special meaning. That means I want to match the previous character 0 or more time. So you can say, I want something in between. I don't care how many times it's, I mean, it can be 0 or it can be any number of time. So that's the meaning of the star. And you have a couple more that basically repetition operators. And that's going to tell you how many times you want something to be there in your pattern. So you have like the plus, that means 1 or more time. And so, for example, if you had this here, you would match word like hello, that has 2 L, but you wouldn't match video because video doesn't have any L between the E and O. And with the plus, you say you want it 1 or more time. With the star, you say you want it 0 or more time. So you would also match video because you actually don't care if there is a L. So you might want any number of L, but this number could be 0. You have the question mark. That means 0 or more time, 0 or 1 time. So that means you will only accept things like video or develop, but LO that has 2 L wouldn't be a match. And you can actually be way more precise. You can specify like the number of time you want something to match. You can also, with a curly bracket, you can basically, it's basically the number of time, so at least n time and at most m time. So if you just put n, if you just put the first one, that would be at least this number of time and any number of time. If you just put the last one, it would be at most m time, and you don't care what the at least is, and so on. So this is like the most general form where you have at least and at most, and you can only specify one of those if you want to. And that's basically either putting an upper bound or lower bound on the number of time you want to match something. And so for all these, you need the -e, which is the extended regular expression. So by default, grep doesn't look into extended. So by default, those symbols wouldn't have a specific meaning. But if you want them to have a specific meaning, you would need to use the -e. And I also put here another one that's sometimes useful that also needs -e. It's not really a repetition. It's more like an OR. So if you want to match potentially two patterns, then you could say put a vertical line, so like the pipe symbol, it's the same as the pipe symbol. You could put R1, then this symbol that would be OR, R2. So you could match a OR with this symbol too. And there is also group, and I need to hurry a bit more. There's also group, which is like normal parentheses. And what a group allows you to do is to say, for example, if you use repetition element, that will say that the repetition operator needs to apply to the group and not just the previous character, because otherwise it's going to only apply to the previous character. So if you had A star, it would match 0 or more occurrences of A. If you write ABC star, it would match 0 or more occurrences of AB, C. So it's only the C that's 0 or more occurrences. So it would match AB, ABC, ABCC, ABCCCC, and so on. But if you want to match multiple ABC, then you will need to put that pattern or that group of letters together in a group. And then that would mean you need to match 0 or more time the group ABC. So you would match ABC, 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 and so on. But the star is going to apply to the full group. And so that can also, if you want to use the OR, but it's not the full pattern that you just want to specify OR, then you could also use the group. So basically this would mean I want to match an A, and I want to match, after my first A, I want either to have an A1 or a B2, and then I want a B. So that would match AA1B or AB2B. So this, and this, or this, the second case, and the last letter. And you could also write that as or between AA1B and AB2B, but it might be more easier to understand with the grouping. And this grouping can also be used to extract match. For example, if you were to say, I want the first letter to be either A and an E, but you put it in a group, then you say the second letter needs to be an N, and then you can use the \1, and the \1 means I want this here to be the same match as my first group. So basically you're extracting whatever the match was in what you put in your group to be put after the N. So in that case, you would match either A followed by an N and follow again by an E, by an A, or you'll match an E followed by an N, follow again by an E. So you would match like banana, Genesis, but you would not match plain because the letter that's follow N has to be the same one as what that was before. So you can also use group for that type of thing. Okay, and there is a couple more like special character or shortcut. Like, so I told you before / is an escape character, so it can remove special meaning to the next character, but it can also add special meaning to some characters. And like it had special meaning to those character. For example, if you put a / before them, so \s would mean a space. I mean, you can type a space, that also works. You can type \t, which means a tab character. So like if you want the end of one field to finish by something, and so if your separator is a tab, then you could specify that you want it to be followed by a tab so that you're sure it's the end of one field. And you can also have the \n, which is a new line. But I guess you probably would often use the anchor instead of the new line. But that's also, here's a / add special meaning to the end character. Yeah, let's try some more of these new operator we saw, like mostly repetition operator on our file. Try with me. And so here, for most of them, except the second one, we need the --E. there is a question that is there a way to grab uppercase character only or lowercase character only? Yeah, I mean, you would need to specify it though. So if you put a pattern that's like AZ, then it would only be lower character. So any letter that's lowercase. And if you wanted to put any upper character, then you would just put capital A -Z, so it would be any letter that's upper. So you could use that. I don't think there is a, in terms of the flag, I don't think there is a flag that say, I want it to be upper or lower. You can just say either you want case sensitive or case insensitive as term of flags. So if you had something that has lowercase and uppercase and you only want to find match that are lowercase, then you would need to specify like AZ for the letter. But so when it's case sensitive, if you write a pattern that's only lowercase, then it's going to only match the lowercase patterns. So if you want to match both lowercase, you would write both in lowercase. And if you were to want to match it in uppercase, you will need to write it in uppercase. So by default, it's case sensitive. So if you want, you put the case you want, and you can tell him you don't want it to be case sensitive. So let's try some of these repetition elements. And for those, we need the -E. Let's try again with the color so that we see what's happening. So you can try the OR. So we can say here, we want to match either A1 or B1. And let's try again our regex2.txt. And we can see in the match here, we're matching A1. We're matching also B1 here and here. You could also do that without. So there's often multiple ways to do the same thing. So you could also have written A, B in the character class, followed by 1. Just say, I want the first character to be A or B, and then followed by 1. And that actually doesn't need the -E, because it's like normal. I mean, it would work with the -E, but it doesn't need it. And then you'll have the same match. So there are often multiple ways to match the same pattern. And we can try more patterns. So if you were to try A+, and that's a repetition element that needs the extended regular expression, so I need to add the -E, then you see it would match everything that has an A or more. So here it's matching 3A, here it's matching 2 A's, and so on. And so the A is one or more time. So plus is one or more time. You can also specify a number. So we could specify we want to find 3 A's and only 3 A's. And here you see it's only going to answer this line that has 3 A's because we said to him we want to match 3 A's. And you could match, for example, 2 or 3 A's. So that would be these. So you can use this repetition element when you want to allow any or more possibilities. And yeah, we have multiple. So if we were to match, to group A, B, C and put a plus, here we would match the full group A, B, C one or more time. And we can, well, we only have one time, but you can see we match a full A, B, C. And this one is not a match because it's capital case. And we could specify we want insensitive. And then this one would be a match because it has twice ABC. Because I added the -I, which is case insensitive. Yeah, I'm not going to necessarily do all the examples, but feel free to try those examples. I'm going to just show you this one because you need to be a bit careful. I mean, it's usually good to try things that should match when you use regular expression to make sure that you are really matching what you want to. So I will often just try a small example to make sure my pattern is matching what I want. So let's try to match 2 A's and only 2 with this curly brace. And so what you can see is we still get this line that's actually 3 A's, but it only matches the first 2 because I didn't specify anything following. So basically, I actually don't care what's following. So it did match the 2 first A of my 3A and the 2A that's here. So if you want something that's really 2A and not followed by another A, you need to specify to it that it shouldn't be followed by another A. And so you can do that with like this pattern that's a bit complicated. And that's why you need to try to make sure you're matching what you want. So this means here, I want either to start, or if I'm not starting the line, I want the letter that's following my 2 A's to not to be an A. And then you need to do the same for the end. You need to say either my 2A are at the end of the line, or they're not followed by an A. So that's basically what this regular expression means. You just need to specify what's before and after the A. So if you wanted, if you wanted to, if you wanted 2A between B's, that would work fine because you had B's, then A, then curly brace 2, and B. And because you specify what's after the 2A, that would totally work. But if you just want an exact number of A and you don't know what's after and before, you need to specify what's after and before. So if I say here, I want either my line to start, or I want not an A before my 2 A's, and basically the same after. I want either my 2 A's to be at the end of the line, or to be followed by not an A. Oops, sorry. And that works. So now you can see that it actually matches the B, and I forgot to color it on the left. So you can see that it matches the next letter, which is a B. And that's what we need. We need to tell him that it shouldn't be an A that's following after. And if I wasn't to put it has to start, then if you had, actually, I'm gonna try that. If I wasn't to specify that's what's need to be before, it would still match this one because it would just match the last 2 of them. It wouldn't match the first one because we say it has to be at the end of the line or not to be followed by A, but we didn't specify before. So that would still work because the last 2 still match the regular expression. So sometimes you think a pattern is quite easy, and it's not always easy. So that's why it's really good usually to try and make sure that you get your pattern right before necessarily doing it on a big file, just to try a couple of things that should work and should not work and make sure it works the way you want it to be. Mostly when you have repetition, you need to be a bit more careful. Yeah, so I'll let you do that later. I'm going to add this file that I forgot. I'm going to, just after the class, I'm going to add it to the GitHub so that you can re-download and try this thing on the GTF. But basically with what we learn, before we try just to put chromosome 2, but now with what we learn, what you should do if you wanted to extract only the chromosome 2 would be to, ideally you would anchor it to the beginning of the line because that's the first field. So you would anchor it to the beginning of the line, and then you'll specify that the 2 has to be followed by a space, because in this case, it's like space separated. So you would have to say that what you want after the 2 if you don't want. Or you could say you don't want any number. This way you wouldn't have 21. And then if you do that, then you'll see that you're going to end up with only genes that are on chromosome 2. And so that's why it's good to try your regular expression to make sure it works as you want it to work. Oh yeah, we still have that. I mean, it's relatively short. So sed is another way to process text file. And sed, what it means is a stream editor. So it's a way to edit file in a non-interactive manner. So if you have a big file where you want to edit in a relatively simple way, then you could do that with sed. And this way you don't have to open the file, which can sometimes be hard when it's a huge file. And so the way sed works, you have some flags that you can set, and you have like a sed, kind of like a sed command. It's going to be a command that's going to be understood by sed, and then you're going to specify on which file you want to apply that. And so what you can do with sed is do editing tasks like find and replace. So you can find a pattern and replace it by something else. You could delete lines, for example, or add lines. You could, yeah, insert line or delete some stuff, some specific line. So by default, sed is going to print the output on your screen. So you might want to redirect to a new file. And so as before, you should never try to read and redirect to the same file, because the redirection is kind of happening before. And so it's usually not a good idea to read a file and redirect to the same file. So always redirect to another file name. We've said if you want to change your file, there is a flag that says that. So don't use the redirection symbol, use the flag for sed. The flag is -I, and that means replace in place. So if you want to do that sed command and modify your file, don't redirect to the same file name, use the -I. And as with grep, you can have extended regular expression. So grep only search for a pattern. With sed, you can search for a pattern and replace by something else. So sed going to be useful mostly in 3 cases: when you have very big files that it's hard to edit interactively, when it can be complicated for a regular text editor, and it can also allow you to do multiple editing in one go, because you can add multiple sed command, or you can even pipe them or things like that. So that can allow you to do multiple files at the same, multiple like edition at the same time. So how does it work? So you would have sed, then you need the command for sed, and sed has a couple of commands. So like substitute, you can, that's a find and replace basically. So you would substitute a pattern by a new pattern. And so basically to tell sed you want to substitute, you need to start the sed command with an S, that means substitute. And then you need to add some delimiter. Usually people put slash. At least for the substitute, you can put any character. So you could put like a $, or as long as it's repeated here and here, it will understand that's a pattern. It's easier if the delimiter you use is not something that you use in your pattern. Then this way you don't have any conflict, or it's easier to read. And then you'll specify a file name. So we have a file that's called fruits _ sed. So if I show that, we have a bunch of fruits again. And so we can try, for example, with sed. So let's do sed. Then I'm saying to sed, I want to substitute orange. So I'm putting the delimiter here. I'm putting a slash. So I want to change orange. I want to find the orange and replace them by cherry. And then I can put, so you need that in quotes. And I want to apply that sed command in my fruits _ sed. And if I do that, you can see what it did. And so here I colored so that easier. And we can see that it only changed the first match. So it's only gonna change the first match. And so that's why we still have cherry. And here we only have one orange in the line. So it's also working kind of line by line. So it's gonna look at every line. It's gonna find the pattern and replace it. And so here it find orange and replace orange, but it only did that on the first one. And here there was only one, so it did change. And so when you substitute, it only applied to the first substitution, the first match on your line. You can tell him to apply on all of them. And for that, you need to add this G at the end of your set command. And this G means apply this find and replace globally. So on any match, whatever, like on any match of your file, not only the first one. So if we run the exact same command, but now I'm going back and I'm adding this G just at the end of my set command, just after the slash, after cherry, then you see now it also modified the second orange of this line because I specified to it I wanted to apply globally. I guess that's what you're gonna use most often. So I was saying you can use different delimiter. I mean, slash is totally fine. As long as you don't have slash in your pattern, it's gonna be fine. But if you have a slash in your pattern, then you might want to use another delimiter. And usually you would always do, I do use sed mostly for find and replace. So you would do usually S and always put the G because usually you tend to want to find and replace everything, not just the first match in the line. Yeah. You can also specify with sed, you can also specify on which line you want this to apply. So if you wanted to apply this pattern only between a specific set of line, you could write the line number, comma, the line number. So it would only apply between the line X and the line Y. So you can be a bit more specific when you do your set command and it's saying you want to apply it to specific lines. So if I go back to my set command, and if I just go back at the beginning, and if I add just at the beginning of the command, just after the quote, if I had 4, $sign, for example, so $sign mean until the end of the file, so until the last line. So if I were to write 4, $sign, that would apply this search and replace pattern only to line 4 up to the end. So in that case, you see that it replaced the orange that was at the line 4, but it didn't replace the orange that was at line 2, because I specify I want it to apply only from line 4 and to the end of the file. Okay. Oh, we still have a bit of time. Okay, so yeah, you can try. So for example, I'll let you try a bit on your own that. I mean, you have the output, you can see. I'm gonna, yeah, so here you're gonna try to find the pattern orange and you want to replace it by, well, the same pattern, but you want to put parentheses around orange. So you could do that. So you search for orange, then you put parentheses around orange. There is a couple of shortcuts where you could do that. So there's actually the and sign means a match text. So if you were to put the and sign here, it would put orange because that's what you search for. So here you would replace orange also by parentheses around the orange with the and sign. I'm gonna do this one, I guess, so that you can see. I mean, you can do it too. So the and sign is gonna mean, and I'm gonna leave the 4. So here I'm gonna replace orange by orange in between parentheses, but only from line 4 to the end of the file. And so if I run that, you can see that I replaced the orange in line 4 by orange within parentheses. And you can also do that, as I told you before, we can use parentheses in a pattern to make a group and use that to basically extract the group. So that's another way to do the same thing. But for group to work, you need to have the extended regular expression. So that's why here I added the dash capital E in the set comment. But that's exactly the same. So here I'm grouping orange. So here I'm matching with the extended regular expression orange, and I'm making a group just to be able to extract it and re-put it in my output. So that would give you the exact same output. So that's like 3 ways of doing the same thing. So with like Linux and Bash, or you often have multiple ways to do the exact same thing. You can also delete lines. And so the command to delete line with sed would be sed. Then similar to substitute, you can specify the line you want to delete. I mean, you will specify the line you want to delete. It can either be x, y, and that would be from line x to y. And then instead of having s and your pattern, here you just have d, which means delete. So here you would say, I want to delete the line from x to y, and then you can write your file name. So if we do that on our fruit, I'm gonna just remove the set pattern. And so I'm gonna write 1d. Yeah, so that would be my set command, the 1d, and then that would mean delete me the first line. And the first line was apple, and we can see that it deleted apple. You can say delete from line 1 to 3, and then it would delete apple, orange, orange, and banana. So I would only have orange and pear left. And you can also, as before, specify from line to the end. And if you want to the end of the file, then it would be the $sign. You can also delete line based on the pattern. So you could start your set command with a pattern, and it's going to delete line where this pattern is found. So if I was to say the pattern is AN, so AN in my file will be found in banana and oranges. So I would only have apple here and pear here. That should be left. So here I'm saying I want to delete all the line where you find this AN pattern. And then you see I only have apple or pear. And you can also insert new line. So it's kind of similar. So you have you can specify on which line you want to work. Then you need to specify what type of set commands you need to do. So here you would say I for insert, and then you need to say what it needs to insert, and then whatever file name you want. And so what it's going to do is before every line you specify, it's going to add a line with that specific text pattern here. So if I do it on my fruit, let me change my set command. We can do before the first line, add insert, and I want to insert kiwi. And if I do that, then you see it added a new line before the first one with kiwi. And you can say that I want to add kiwi before line 2 to 4. So if I change the line number to 2, 4, it's going to insert a line with kiwi before the second line, before the third line, and before the fourth line. So you'll see here I have apple, then I have kiwi, then I have my original second line, then I add kiwi again, then I have my original third line, then I add kiwi again, and then I have my original fourth line. And also, as before, you can also specify a pattern. So you can insert thing on the line before where a specific pattern is found. So as with the delete, you could search for a line that include a pattern, and then you would insert something before that specific line. And so the pattern that's here would be the pattern you're looking for. And that second pattern is the pattern you would insert. So that's a new line you would insert. So if you are to do that with this command, so you'd look at every line that has an AN, and then before that line, you would insert kiwi. And we can see here, it does the same. It's insert kiwi on the line before oranges, and same before banana, and same before oranges, because it found this pattern on line 2, 3, 4. Okay, and you can also append line. So append is basically the opposite as insert. Instead of inserting before, it's going to insert after the line. And the rest is exactly the same. So you just need to change the I into an A. And so here you would insert the pattern after line X and Y. So if I do exactly the same as before, I'm gonna do that. So here I was inserted before the first line. So if I change the I into an A, then I'm gonna insert after. So you see now I'm inserting kiwi after apple and not before. And similarly, if I reduce the 2 to 4 with an A instead of an I, then I have my second line, and then I'm inserting after. Then I have my third line, and I'm inserting after. And then I have my fourth line, and I'm inserting after. So that's for sed. And same, you can also have pattern. So you can match line with pattern and insert after them a specific thing. And as I was mentioning, don't read and write in the save file. So don't redirect, don't do sed, a specific file, and redirect to it. You're just going to lose basically everything. It's not going to work. If you want to modify it in place, use the sed command -I. That's insert in place. I have a couple of questions. I had one about Excel file. So Excel file is not technically very classical file. In Unix, you mostly have text-based files, so you could have you could export as CSV very easily. I'm not sure you could export the Excel format directly, but if you have a CSV, so in Excel you could export to CSV and do that with the Linux command. So use the CSV. I guess, yeah, I would recommend to use a CSV. So if you want to work on like Excel-like file, export a CSV and then work on that file in Linux command. And if you want to save something that you want to open with Excel, I would also recommend to export a CSV and open and import that CSV in Excel. And second question was, can I insert or append multiple line of kiwi? You probably can, and you think you would. I'm not sure how you would do like any number. If you wanted to insert 20 line of kiwi, it could be hard. But what I think would work is putting the \n, because \n means new line, and then another kiwi. Then I think that would insert 2 line of kiwi instead of 1. And so, yeah, so you can use the \n, which means new line, in your insert or append thing. So if you were to want to do that 20 times, I'm not sure that would be very convenient, but otherwise you can use this \n to add 2 lines of kiwi before. You can also have multiple sed command, and you could pipe multiple sed. So you could first add a first line of kiwi and then pipe into another sed that add another line of kiwi before any line of kiwi. So you could probably do some script that you give a number and would do that, but I probably would do some script. It might be hard to do in one single sed command. If you were to add 20 line of kiwis, and if you don't want to write 20 times kiwi \n kiwi and so on. But if it's only 2, then I would just put a \n to say new line and put again kiwi, and then you'll have your 2 line of kiwi. Okay, so that's it for today. So we'll just a quick summary of what we've seen today. And so what we've seen today. So we've seen a couple of commands that allow you to visualize files. So we saw cat that just print whatever the content of your file is to your screen. We saw less, which is easier to when you have bigger files because it's show it to your screen, but you can scroll in like with pages. So like in the manual, you can scroll up and down by pages. So if you have a long file, that can be easier. We also saw head and tail, which allows you to only print the top of the file, so the beginning of the file or the end of the file. We saw cut to extract specific field. So if you have column in your file and you're only interested in specific column, you can extract this column using cut. We saw past that can join file line by line. We also saw WC, which means word count, which can allow you to count the number of word or character or line in your file. We saw diff that allows you to compare two files. So if you have a script that you modify and you forgot exactly what's the difference, then you could use diff to see more easily what's the difference between the two. We also saw how to sort a file by a specific column, either numeric or alphabetically and so on. We saw unique to filter out only unique line in a file. We also saw how to redirect the standard output to a file instead of printing to the screen to save the result in a file, either by overwriting that file or by appending to a file. We also saw how we could write more complex command in only one line using the pipeline command to be able to just send the result of the first command to the new command and so on, and not having to save intermediary file. We also saw grep, which allows you to search specific pattern in a file, and sed, which is a stream editor that can do substitution on a text file in like substitution, deletion, insertion, and so on text file without having to open that file. And when we're playing with regular expression, we also saw echo that allow you to print something to the screen very easily. And so here you have, so at the end, so in the presentation, we're not going to do that right now, but if you want to practice, you have a couple of exercises that you can do. And yeah, feel free to try that. And we'll go through that tomorrow, the result. And so that's kind of, I think that's the end. Yeah, so that's my answer. So that's going to be for tomorrow. So we'll go through the answer tomorrow. So that's all for today. If you have any question, we still have like 3 minutes, 5 minutes. You'll have the slide in the box, and I'm going to update the files if you want to try the thing with the GTF that I forgot to put. So I'm going to update the GitHub file for today. So if you want to try, feel free to re-download it. I'll do that just after. See you tomorrow. And yeah.